Hi everyone, welcome to the next lecture on Fourier series. In this video, we are going to discuss the many important points of half-range Fourier series. As you know, in the previous lecture, we have discussed the many example of Fourier series with different intervals. So our function is defined in the interval 0 to 2 pi, minus pi to pi, or sometimes it is in the form of constant. But here, this question is find Fourier Sine series and cosine series for the function f of x is x square in the interval 0 to pi. So it is not even function, not odd function. We have to find a half-range Fourier series. So firstly, I will discuss the concept, what is a half-range Fourier series and how to remember that formulas, and after that we will solve this question. So what is half-range Fourier series? First of all, if we have given the function f of x and question is find Fourier series, as here interval is 0 to 2 pi, 0 to pi. So let's suppose I will consider Fourier series f of x is a0 by 2 plus summation n varies from 1 to infinity, and if our interval is minus pi to pi or 0 to pi, so that time our function is an cos nx plus bn sine nx. So this is the Fourier series for the function f of x. Let's suppose in the interval minus pi to pi. So I am considering our function is defined in the interval minus pi to pi. So this is our Fourier series formula for the function f of x in the interval minus pi to pi. Now if our function is even function, so what will happen if our function f of x is even function? So we know that for even function only need to find the a0 and an. So if our function is even, so then bn is 0. That means here we have to find only a0, and when our function is even, so when there is an integral minus a to a, it becomes 2 times 0 to a if our function is even. So here it is a 2 by pi integral 0 to pi f of x dx. And to find an formula is again 1 upon pi integral minus pi to pi f of x into function, here it is a cos nx dx, and here cos is even function, f of x is even function, and for even function integral minus pi to pi become twice 0 to a. So here also we can write it is a 0 to pi 2 times integral 0 to pi. So if our function is even, so then value of bn is 0 and an and a0 we can find with this formula. Now if we put this value in this function, so that means we will get the function f of x, that is a Fourier series for function f of x is a0 by 2 plus summation n varies from 1 to infinity an cos nx. So when our function is even function, so Fourier series is only up to the value an. Now if our function is odd function, so what is the condition for odd function? If our function is odd, so this integral minus a to a f of x, for odd function it is 0. If our function is odd, then it is a 0, and here if our function is even, so then integral become 2 times. So when our function is odd function, so for odd function in the interval minus pi to pi, this a0 is 0. Also here odd multiplied by even. So odd means actually it is a minus sign and even means plus sign. So minus multiplied by plus is minus and minus is odd. So it become a odd function. And for odd interval minus pi to pi, integration is 0. So that means if our function is odd function, so here our a0 is 0 and an is also 0. So only need to find the bn. So when our function is odd, so bn is 1 upon pi integral minus pi to pi f of x into sine nx dx. Now see here, function is odd and sine is also odd. So odd multiplied by odd, minus multiplied by minus is plus. That means this quantity is odd into odd is even function. So this is an even function. So therefore our bn is 2 by pi integral 0 to pi f of x into sine nx dx. So for odd function a0 and an are 0 and bn is this one bn we can find with this formula. So therefore our Fourier series f of x for odd function is summation n varies from 1 to infinity. It contains bn into sine n x. Now if we observe this two Fourier series, so it contains cos, only cos term, so we can say it is a cosine series. And if our function that f of x is contain only sine, so this is a sine Fourier sine series. अब ये जो है फंक्शन इवन या ऑड फंक्शन है, तो तब हम ये कंसेप्ट अप्लाई करते हो, यू विल गेट फोरियर कोसाइन सीरीज, फोरियर साइन सीरीज. अब क्वेश्चन में देखो ये वाला जो टर्म है, इज इट ए इवन फंक्शन और ऑड फंक्शन? तो यहाँ पे आप नहीं बता सकते कि इज इट इवन और ऑड. अब व्हाई? अब इसका भी एक्सप्रेशन मैं देती हूँ आपको. जब फोरियर साइन कोसाइन सीरीज पूछते हैं, तो if they are asking about the sine series, so only you have to find the bn and use this formula of finding bn and f of x. And if they are asking for the cosine series, so cosine series, that means you have to find a naught an with the help of these two formulas, and therefore our Fourier cosine series formula, that is this. So Fourier cosine series for function f of x is this one. तो ये Fourier cosine series और Fourier sine series, ये भले ही हमारा इवन ऑड के कंसेप्ट के जैसे ही है, लेकिन आपको ये डायरेक्ट यूज करना है अगर वो पूछता है तो. अब क्यों? बिकॉज ये जो फंक्शन है ये हाफ इंटरवल गिवन है. हाफ इंटरवल में हम नहीं बता सकते कि वो फंक्शन इवन है कि ऑड है. व्हाई? सी हियर, लेट्स सपोज आई विल गिव यू द एग्जांपल हियर. टेक द फंक्शन f of x is x in the interval -π to π. अब इंटरवल अगर -π to π, फंक्शन f of x is x, so x replaced by -x, so you will get f of -x is -x, that means f of -x is minus, here x is nothing but f of x. So see, it is the definition of odd function. मतलब अगर x यहाँ पे simply x दिया हुआ है, तो this function is our odd function. So when there is a power of x is odd, so that is an odd function. मतलब ये जो रहेगा f of x, otherwise x cube or x raised to the power 5 and so on in the interval -π to π. This all functions are odd functions. So x का power odd है, तो that become a odd function. But इसी फंक्शन को सेम इंटरवल में डिफाइन कर रहा है, बट ब्रेक करके. मतलब अगर मैंने इस फंक्शन को इस तरह से ना डिफाइन करते हुए, if I will write f of x is, here it is a x in the interval -π less than equals to x less than 0, and it is a -x in the interval 0 less than equals to x less than π. So see here also interval is -π to π, but function कैसा है? दो पार्ट्स में ब्रेक हुआ है, और फर्स्ट में x है तो सेकेंड में -x है. सो इस तरह से अगर फंक्शन का ब्रेकिंग किया हुआ है, यू मे राइट हियर माइनस एंड हियर प्लस, तो भी ये फंक्शन करेक्ट है. अब इस फंक्शन को ऑब्जर्व करोगे तो हियर f of -x you will get f of x. This concept I have already discussed when I have discussed about the even and odd function. तो ये सारे कंसेप्ट मैंने वहाँ पे डिस्कस कर चुकी हूँ. उसका लिंक आपको डिस्क्रिप्शन बॉक्स में मिल जाएगा, तो यू कैन वॉच दैट वीडियो, ताकि आपको क्लियर हो जाएगा कि हाउ वी आर रिप्लेसिंग दिस टर्म, और मेनी एग्जांपल्स आल्सो वी हैव डन इन दिस टाइप ऑफ क्वेश्चंस. नाउ सी हियर f of -x is f of x, मतलब हमारा फंक्शन कैसा है? इवन फंक्शन. सो हियर f of x is even function. अब इसमें देखो, अगर मैं हाफ रेंज कंसिडर करती हूँ, तो हाफ रेंज फॉर दिस फंक्शन f of x is x in the interval 0 less than x less than π. अब देखो यहाँ पे इंटरवल 0 to π f of x is x, यहाँ पे 0 to π f of x is x, बिकॉज -π to π अगर x है तो 0 to π भी क्या होगा? x. तो यहाँ पे भी फंक्शन x है, यहाँ पे भी x है इन द सेम इंटरवल 0 to π. बट हियर दिस फंक्शन इज ऑड फंक्शन एंड हियर आवर फंक्शन इज इवन फंक्शन. तो फंक्शन किस तरह से कंप्लीट इंटरवल में कैसे डिफाइन किया है, दैट वी डोंट नो. दैट्स व्हाई यहाँ पे हाफ रेंज फोरियर सीरीज में हम इवन और ऑड ये डिस्कस नहीं करते. कि फोरियर सीरीज साइन सीरीज पूछा है तो डायरेक्टली यू हैव टू फाइंड bn एंड यूज दिस फॉर्मूला. मतलब इसमें साइन है, सो दिस इज ए साइन सीरीज. और if they ask about the cosine series, so directly find a naught and an using this formula. See here it is a 2 by pi 2 by pi. Or then फाइंड द फोरियर कोसाइन सीरीज मीन्स ये वाला फॉर्मूला आपको यूज करके सीरीज को फाइंड आउट करना है। तो ये होता है कोसाइन एंड साइन सीरीज। और फंक्शन जब गिवन है तो उस बेसिस पे यू कैन नॉट से वेदर इट इज इवन और ऑड फंक्शन। मे बी दिखते वक्त आपको वो इवन दिख रहा है बट वो ऑड भी हो सकता है। फुल रेंज के अंदर मे बी वहां पे आपको ऑड दिखेगा बट वो इवन हो सकता है। जैसे यहाँ पे वो दिखते वक्त क्या दिख रहा है, एक्स है तो ऑड फंक्शन, बट ये क्या यहाँ पे एज पर दिस फुल रेंज इट इज ए इवन फंक्शन, समटाइम्स मे बी इट इज ए ऑड फंक्शन। सो दिस इज द मेन कंसेप्ट कि जिसमें हमें हाफ रेंज में यहाँ पे इवन ऑड नहीं डिस्कस करना है, सीधा फॉर्मूला यूज करके यू कैन पुट। वो आता इवन ऑड के कंसेप्ट से ही है बट इस तरह से आपको डायरेक्ट यूज करके सॉल्व करना। सो हियर फर्स्ट वी फाइंड द फोरियर साइन सीरीज। Fourier Sine series. So first we find the Fourier Sine series, and we know that Fourier Sine series that means only we need to find the Bn, An और A0 क्या होते हैं वहाँ पे 0. So Fourier Sine series for the function f of x, that means it is a summation n varies from 1 to infinity, it contains Bn sin n x. The Fourier Sine series formula, consider it is equation 1. So how to find Bn? Bn is our 2 by pi integral, here interval is 0 to pi, half interval you have to consider, f of x sin nx dx. It is a 2 by pi as it is, integral 0 to pi x square sin nx and into dx. Now here we have to use the integration continuous formula that we have already discussed. So I will write only formula. Integration of uv, keep u as it is, integration of v, alternate plus minus, minus derivative of u, integration of v, again derivative of u1, integration of v2 and so on. So here continuous integration formula if we apply here, so we will get Bn is 2 by pi constant term outside as it is, here x square, u is as it is, so x square as it is, integration of sine is minus cos nx divided by n minus derivative of first term 2x, integration of second term, so it is minus sine nx divided by n square plus derivative of again first term, so 2x derivative is 2 and integration of second term, so sine integral is minus, already is there minus, so cos nx upon n cube, limit is 0 to pi. Now put upper limit minus of lower limit. So here sine of n pi and sine of 0 both are 0. So for upper limit and lower limit this middle term is 0. तो यहाँ पे upper limit lower limit put करने की जरूरत नहीं, because for upper as well as lower this term is completely 0. So therefore our Bn is outside 2 by pi as it is. Upper limit is pi. So here if we put pi, so it become a minus pi square cos n pi upon n. Minus of lower limit, x is 0. So here multiplication 0, that means whole term becomes 0. So if we put x equals to 0, so for lower limit this term is 0. Now put upper limit here, 2 constant as it is. Here x equals to pi. So cos n pi divided by n cube minus of lower limit. So it is a 2. Cos of 0 is 1. So cos of 0 is 1. So 2 by n cube. Simplify this term. Cos of n pi we can write minus 1 raised to the power n. And so here it is 2 by pi. This is a minus pi square minus 1 raised to the power n by n plus 2 minus 1 raised to the power n minus 2 divided by, here it is a common division, n cube. In the next step you can take n cube common. So if we take n cube outside, so it is a 2 by pi n cube and remaining is this minus and this minus. So total minus raised to the power n plus 1. That n minus 1 raised to the power n also you can take common if you want. Otherwise here minus 1 raised to the power n plus 1 pi square and n cube we are taking common. So here it is a simply n. So n square multiply and divide, so that denominator is n cube. So this multiplication n square is there, minus plus here 2 minus 1 raised to the power n minus 2. So this is the value of our Bn. So for sine series only need to find Bn. So Bn हमने find out किया. Put this value in formula equation number 1. So therefore Fourier sine series is f of x equal to summation n varies from 1 to infinity. Bn is 2 by pi n cube into minus 1 raised to the power n plus 1 pi square n square plus 2 minus 1 raised to the power n minus 2 into sine n x. So this is the final answer of our first question, that is a Fourier sine series. So in this way you have to find Fourier sine series, जिसमें हमने सिर्फ bn find out किया और bn के फॉर्मूले में 1 upon pi होता है, but because of half range we have to take 2 upon pi integral 0 to pi f of x sin x. And after getting bn we have to put this value in Fourier sine series because उसमें सिर्फ sine वाला term रहेगा, that means it contain only bn. So this is the final answer. Now the second is cosine series. You can try this cosine series. We will discuss the solution of cosine series in next video. Thank you.